Hello coders, Darren here with Renaissance Coders, and today we're going to be implementing our camera collision system from our camera controller.cs file that we've been using for our 3D controller for the past few tutorials. Okay, now you can in essence put this into a separate script if you wanted to, but for the sake of this tutorial I want to go ahead and keep everything together. Alright, now if you need to understand or if you don't understand what I'm talking about in this tutorial and you haven't seen the previous one, you'll want to go ahead and check that one out because I talk about a lot of the concepts that we're going to be implementing here today. Alright, so I'm going to create this class called Collision Handler, and I'm going to draw out the skeleton for us before we start actually writing any of the code for the methods. Alright, so we're going to have this collision layer, the layer mask, which is going to be all of the objects that the camera can collide with. And we're going to have some more members here. So we need to have a bool for colliding. We're going to be using this boolean from outside of this class to determine if we need to move the camera forward or not. Then we're going to have our vector3 clip point arrays. So we're going to have two clip point arrays. We're going to have adjusted clip. We'll call this adjusted camera clip points. Then we're going to have, let's see, hide and inspector public vector3. We're going to have our desired camera clip points. Okay, so the adjusted camera clip points are going to be the clip points that surround the camera's current position. So wherever the camera's position is going to be where the adjusted camera clip points are. The desired camera clip points are going to be the clip points that surround the camera's expected position if it wasn't colliding with anything. Alright, now I'm going to be drawing out the lines for each one of these ray casts that we're going to be doing to these clip points, so you'll actually be able to see them in the next tutorial when we use debug.drawLine. Alright, and then I need a reference to my camera, so I'm going to create this camera right here. Alright, so I'm going to go ahead and draw out some of the methods that we're going to be using. Actually, I guess I'll draw out all the methods that we're going to be using before we actually write anything for them. So we're going to have public void initialize. We need to initialize this class from outside of it within the script, and this is going to be passing a camera to it. Then we're going to have public, actually this one won't be public, we'll say bool collision detected at clip points. This is going to take a few parameters. It's going to take the vector3 clip point array that we want to check. Okay, so we're going to be able to pass either one of these clip point arrays to this method to determine if we have a collision. We're actually only going to be using desired, but at some point, maybe if you wanted to do some sort of fancy work, you might end up passing this clip point array to it. Okay, so we're going to be passing the clip point array, and then we need to say vector3 from position. So from position is going to be our target position, because we're going to be, remember, we're going to be casting rays from our target position to our clip points. Then we're going to have public void update camera clip points. This is going to take vector3 from position. Okay, so from position is going to be our camera position in this case. So actually, what I'll do is I'll actually just call this camera position, so it's not confusing. Okay, so vector3 camera position, quaternion at rotation. So we want to make sure we don't just define our clip points positions. We have to rotate those positions based on whatever the camera's rotation is at. Okay, and then what the next thing we need to do is pass a ref to our vector3 array, and whatever array we want to put these clip points into. All right, so this method again is going to be it's going to be called roughly every frame, and what we're doing with it is just filling the clip point arrays. So we'll be passing the desired clip points into here and the adjusted clip points into here to refresh the new clip points, because remember our camera is going to be moving around the scene each frame. Okay, so we need to make sure we update those clip points as it moves. All right, then we're going to have a public float get adjusted distance with ray. It's going to be taking a vector3 called from. Now what this method does is it returns the distance that our camera needs to be from our target. So whenever there is a collision, we want to make sure that we find the new distance the camera needs to be from the target, and we make sure that we move it to that position. All right, now we're not actually going to be moving it to the position within this method. We're just going to be returning the distance that the camera needs to be from the target. So again, we need this method to essentially, this is going to be what determines how far we move our camera forward whenever there is a collision. And then finally, we're going to have a public void check colliding, which is going to be called in fixed update. And let's see, we need to actually pass the target position to this. So target position. Alright, and what this is going to do is it's just going to update our colliding boolean, and what we'll do from outside of this class is check to see if colliding is true or false, and it's going to be what determines how we're moving our camera at that particular moment in time. Alright, so let's go ahead, and since we've outlined each one of the methods, we're going to start filling in the code required for these methods. Now in our initialize method, what we're going to do is set the camera first of all, so camera is going to be equal to cam. And then what we're going to do is just initialize our clip point arrays. So adjusted camera clip points is going to be equal to new vector3 5. So remember, these clip point arrays are going to have 5 points contained within the 4 clip points on the near clip plane and the camera's position. So that'll be five total points. Alright, and then we do the same thing with the desired clip points, set that equal to a new vector3 5. Alright, so that's going to cover our initialize method. And then we have our collision detected at clip points method. Okay, actually before I do that one, I want to go ahead and actually want to order this a little bit better. First we want to determine how we get our clip points, and then after that we'll start doing all the work that we need to with those clip points. So how do we get our clip points? The first thing we want to do with this method is check to see if we have a camera. So if not camera, if we don't have a camera, we want to go ahead and return, because there's nothing that we can do with our clip points if we don't have a camera. Alright, and so once we've done that, we can go ahead and clear the array. So remember, we're going to be passing this array called into array, whatever array we're going to be passing our new clip points to. We want to go ahead and clear that out for new clip points, because remember, as the camera moves, we're going to be getting new clip points. We want to make sure that we clear the contents of that array before we add anything else to it. So clear the contents of into array. So what we do is say into array is equal to new vector3 5. Alright, so this sort of refreshes that array. Now what we want to do is, if you remember from the previous tutorial, we have to find the XYZ coordinates for our clip points with relation to the camera's position. So what we're going to do is say define these. Now I'm not going to go into too much depth of how these equations work. I talked about that in the previous tutorial, so I'm just going to go ahead and sort of write them out. So our Z component is going to be equal to camera.nearClipPlane. That's the distance from the camera's position to the near clip plane. Our float x is going to be determined by mathf.tan camera.fieldofview divided by 2. Now we said 2 in the previous tutorial. What this value is really going to do is determine how big of a cushion or how small of a cushion we have between our camera's position and the collision. So what I did was I modified this to 3.41f. I found that was a good value, a good cushion size for our camera to collide with. You can modify this value to increase the size of your collision space. So you can go ahead and play around with that value if you feel like you need to, but 3.41f for me felt pretty good. Alright, and then we're going to be multiplying this by z. Now float y is going to be determined by, remember we're going to be using the aspect ratio to find y, and what we can say is x divided by y is equal to x divided by camera.aspect. Alright, so we'll go ahead and just double check these to make sure these values are correct, and they look okay, so I'm going to go ahead and move on. So at this point what we need to do is we need to find the clip points for each one of our 4 clip points on our near clip plane, and then assign those to our array that we're passing as a reference to this method. So we're going to find the top left, top right, bottom left, bottom right, and then the camera's position. That's going to be our 5th point inside the array. Now to find the top left, what we can do is say into array, the 0th position is going to be equal to @rotation, because we're going to be passing this rotation value to our update camera clip points method. Remember, we need to rotate our vector3 point with the camera's rotation. So we say at rotation times new vector3. This is where we're going to be passing our x, y, and z. Now, what's going to be different between each one of these clip points is going to be whether or not these are negative or positive values. Then we're going to be adding this to our from position. Actually, we called it camera position. So we're adding this to our camera's position. Alright, so what we've done here is we've added and rotated the point relative to camera. Alright, and we're going to be doing this for the next 3 points. So what we can do is, actually let's see, top left. Okay, so top left is going to be negative x, y, and z. Okay? So remember, we have our camera's position, if you can imagine right here, and then we need to go to the top left corner. We need to go negative on the x and then positive on the y. Alright, so let's go ahead and copy and paste this so we don't have to rewrite all of that. Let's see, copy and paste. Alright, and this is going to be 1, 2, and 3. Alright, now for the top right, we're going to say it's x, positive x, positive y, and z. For the bottom left, it's going to be negative x, negative y, z. Our bottom right is going to be x, negative y, and z. Now our fifth position in our clip point array is going to be the camera's position. So we can say into array is equal to camera position minus camera.transform.forward. Now I'm saying minus camera.transform.forward. The reason is because it'll give us a little bit more room behind the camera to collide with. That's what that position is going to do. And in the next tutorial, we're actually going to be drawing the lines that go to each one of these points. So you'll actually be able to see the pyramid shape that the camera is looking to collide with. Okay, and once we've done that, we've completed this method. Alright, now the next method is going to be collision detected at clip points. So we're going to be determining if there is a collision with any of these clip points. So what we do, first thing we do is we loop through our desired array. So our clip point array. So I is equal to 0, I is less than clip points dot length, I plus plus. So we're looping through this, and we need to define a ray to cast our ray cast in. So we're going to define a ray, and we need to define the distance that ray is going to go. So float distance. And what we're going to end up doing is saying if physics.raycast ray distance and collision layer. So remember, the collision layer is all of the objects that it's going to be all of the objects that the camera can collide with. And if we run into something, so if we cast a ray at this distance and it runs into something on the collision layer, that means that we can return true. So we'll say return true. Otherwise, we're going to have to return false. Okay, now what we need to do is define this ray and define this distance. So ray is going to be equal to a new ray, and the ray is going to be moving. Let's see, where do we want this ray to start? We want it to start at the from position, okay, which is actually going to be the target's position that we're looking at, and the direction that it's going to be moving is toward the clip point. So to get that direction, we're going to say clip points at I minus from position. So that's going to give us our direction. And our distance is going to be equal to a new vector, I'm sorry, not new vector3, but actually just vector3 dot distance clip points at I. It's going to be the first parameter, and the second parameter is going to be from position. So all we're doing is we're calculating the distance between our clip point and our target position right here. Alright, so that's going to complete this method. So again, just a brief overview, what we do is we cast a ray at this position and this direction for this distance, and if it runs into our collision layer, we are going to return true. Otherwise, we're going to return false. Alright, now with this get adjusted distance with ray, remember, this is going to return a distance that our camera needs to be from our target. So this is only going to be useful if we actually have a collision. So what we do is first we define a distance. So we can say float distance is equal to -1. Alright, so we know that if we get through this method and distance is still equal to -1, that means we haven't collided with anything, which means we don't want to move our we don't want to move our camera any distance at all. So what we'll say is if distance is equal to -1, we'll just return 0. And then otherwise, we will return distance. So whatever that new distance value became. And what we do in the middle of all this is we set the distance. So the way we set the distance is we are going to loop through our desired clip points array. So int I equal to 0, I is less than desired clip points dot length, I plus plus. Looks like Visual Studio moved this over for me. How convenient. Alright, so I'm going to go ahead and move these back really quick. Okay, so now we can actually add the code that we are setting the distance with. So again, we loop through our distance, we loop through our desired camera clip points array. And what we're going to do is another raycast, but instead of calculating the distance, instead of determining whether or not we are colliding, we are going to be finding the shortest distance between any of the clip points that are colliding. So remember, at any time you could have anywhere from 1 to 5 collisions happening, since we do have 5 collision points. Okay, so what we want to do is find the shortest distance between each one of those collisions and return that at the end of this method. So the way we do that is first, again, we define our array, then we're going to have a raycast hit. We're going to call this hit, and then what we do is we say if physics.raycast ray out hit. Okay, so what happens here is if this method returns true, then we put a value into hit, which is going to have the hit info. In other words, wherever the raycast had a collision at that specific point, we can actually find that from this raycast hit variable. So what we can say is first, if distance is equal to -1, that means it hasn't been set yet, so we want to go ahead and set it. So we say distance is equal to hit.info, or hit.distance. Okay, so this means it hasn't been set yet, so we're going to go ahead and give it its initial value. Otherwise, distance already has a value, so we want to compare. So what we do is we say if hit distance, remember we want to find the shortest distance, so we say if hit distance is less than distance, then what we do is we set distance to hit distance. So hit distance is equal to hit.distance. And so what this is going to do for us is it's going to look through all of the collisions that we have currently and find the shortest distance to have our camera from our target. Alright. Now we've done all that, we need to define our array. So our array is going to be equal to a new array. It's going to be equal to a new array. And the start position is going to be from. Remember, we passed this vector3 from. It's actually going to be our target position to our clip points. So it's going to be from and then desired. So the direction that we want to move in is desired clip points at I minus from. And this gives us the direction of the target position towards the desired camera clip point. So we have our array now. And again, we check to see if the physics raycast returns true. If it does, then we get a value for hit. So we get this hit info from wherever the collision happened. And then what we do is we determine the distance. We can actually find that hit distance, which is calculated from the from position to wherever the raycast was hit. Alright, and we go through and we loop through until we find the shortest distance. Once we have that shortest distance, we can return something, which is what we do right here. Alright, now on to our last method before I close up this tutorial. It's going to be our check colliding, and all we're doing here is determining whether or not we are setting our colliding Boolean to true or false. So what we do here is we say if collision, let's see, what is the name of that method that I created? Collision detected at clip points. Okay, so if collision detected at clip points, we are going to be passing desired clip points, and our from position is going to be our target position. So we are passing the target position right here. So if this collision happened, so if we casted the ray from our target position to our clip points and some collision happened with one of those clip points, that means that we can return true, because in that case a collision happened. Otherwise we want to return false. Actually, I'm sorry, we're not returning, we're actually setting our colliding boolean. So we say colliding is equal to true and colliding is equal to false. Okay, so if we have this collision with our desired camera clip points, then we set colliding to true, otherwise we set colliding to false. Okay, so that is going to conclude this tutorial. We outlined all of the methods and members of this collision handler class. In the next tutorial, we are going to go over how we're going to use this class within the rest of our camera controller CS file. So how are we going to incorporate that class into here to actually get our collisions happening? Currently, the collisions, actually we've changed nothing really. We've created a class, but we haven't done anything with it. So again, in the next tutorial, we will go over what we need to do with that. Okay guys, drop a like if you like this tutorial. But as always, thanks for watching, and we'll see you in the next tutorial.